Okay, good day everyone. My name is Musa Zaradin. I'm going to take you algebra. It's more of introduction to algebra because we're not going to go that deep. So, as I said, algebra. For algebra, the basics, as its name goes, is most of our quadratic equations. So that's where we are going to start. We are going to start with quadratic functions. Quadratic functions. Now, quadratic function, any function that is given in terms of this is what we call a quadratic equation. So A, B, C are all constant. Constant whereby constant means any number. So A, B, C are any number. But A must not be equal to 0 for it to be quadratic equation. B and C might be 0, but A, which is with this x square, must not be equal to 0. For example, if I take, let's say, f of x is equal to ax squared plus c is equal to 0. Here, clearly, it means it can be written in this form: ax squared plus 0x plus c is equal to 0, whereby your b is equal to 0. This is what we call a pure, let's say, perfect quadratic, whereby your b is equal to 0. And there may be situation whereby you can have your f of x to be equal to, let's say, ax squared equal to 0. In this term, your c is equal to 0, your b is equal to 0. So all these are equations. All that matters is your a must not be equal to 0 for you to have a quadratic equation. So let's take an example and see. We have, if you are given your f of x to be equal to, let's say, 6x squared plus 4x equal to 0. This is a quadratic equation. Number 2, we have f of x to be equal to 9x squared plus 3 equal to 0. This is a quadratic equation. Also, we have f of x is equal to x squared plus 4x plus 3 equal to 0. And finally, we have of this form f of x is equal to 8x squared is equal to 0. So all these are what we call quadratic equations. Now all these four are the form whereby a quadratic equation can be written. So anywhere you see something like this, you know it is a quadratic equation because the power of x must be 2. The highest power of x must be 2, as we all see here. So each of these quadratic equations, let's say in general, quadratic equation can be solved using 3 methods. Should I say yes? 4 methods. But we normally use, or should I say, preferably in this topic, we go with the 3 method of solving. There are three methods of solving quadratic equations. So the first one is what we popularly known as factorization. Then the second one, formula method. The third one is factorization, graphical method. Then, as I said, there are four, but we normally use three. So the fourth one is completing the square. So we have factorization, formula method, graphical method, and completing the square method. Of all these four methods, we rarely use this number 3. This number 3 is the one we hardly use because it involves using of graph. So the basics are factorization, formula method, and completing the square. But as time goes on, we may be able to touch a little bit of a graphical method. So now let's take the first one. Let's take factorization method. As I said, factorization as it, from its name you can be able to figure out the word factor. It means every quadratic equation must have factor. It may be one number, it may be double. So how are we going to use factorization method to solve a given quadratic equation? We all know that if, let's take an example, let's say if I said AB is equal to 0, then this is only true if and only if I said AB is equal to 0, this is true if and only if either A is equal to 0 or B is equal to 0 or both are equal to 0. So that's what factorization is all about. You should be able to factor out two factors whereby when you multiply them, because we all know factorization is always equal to 0. So we need two factors whereby when you multiply them, you end up attaining 0, which means this right hand side of something like this must be equal to the left hand side. The right hand side must be equal to the left hand side. So this, you have two factors whereby if you multiply them, you have 0. So that means either of them is equal to 0. Now, let's take an example. For example, you are given an equation. Let's say x squared plus x minus 12, and you are asked to solve this using factorization method. First thing you do is you find a number. Let's say you go to your rough work, for example, you find a number whereby when you add it together, you have plus x. Whereby the same number, if you multiply it together, you have minus 12x squared. If you add the number, you get plus x. When you multiply it, you get minus 12x squared. So preferably we focus on this side because it is the bigger number. Factors of 12 are 2, 3, 4, 6, and 12 itself. Let's see, 12 itself, then we include 1. There have to be even number of factors for every factor. So 1, 2, so if you multiply 1 and 3, 1 and 12, you have 12. 2 and 6, you have 12. 3 and 4, you have 12. So you can say 1x, 2x, 3x, 4x, 6x, and 12x. So when you multiply this, you have 12x squared. But we are looking for minus 12x squared. So all of this number, you multiply, you have only plus x squared. And none of this number, when you add them up together, you have plus x. Then why not let's take these two numbers? Because the difference between these two numbers is 1. So the difference between, let's say, 4 minus 3, but we are adding. So why not let's say minus 4, let's say 3 plus minus 4, we are going to end up arriving at minus 1. Hope you understand. So minus 1. So definitely these two numbers are what we need. You can interchange them by saying minus 4 plus 3 is still minus 1. And if you multiply them, you have this. So that's what we are going to do. We will have x squared. Take the first one plus 3x. Take the second one minus 4x minus 12 is equal to 0. So comprising of these two, you will not take these two together and these two together. So x squared plus 3x plus minus 4x minus 12 is equal to 0. From here, there's something that is common. What's common here is x. So you end up having x plus 3. What is common here? If you remove minus 4, here also you can remove minus 4. So you have minus 4x plus 3. Now, in case you are confused here, you can go back to your, how should I say? You can go back to your rough work and open up this bracket and see whether you go back to this position. And if you do, you go back. You will still go back to this position. So from here, you take this and this middle term. So you have x minus 4. Then this, since this is common, you take 1, x plus 3 equated to 0. Then from here, like I said, when two terms are multiplied, either one of them is equal to 0 or both of them are equal to 0. So in this case, x minus 4 is equal to 0, or x plus 3 is equal to 0. So if x minus 4 is equal to 0, then you move this to this side, you have x is equal to 4, or x plus 3. If x plus 3 is equal to 0, x is equal to minus 3. So using factorization, the factor of this equation factors of this equation that we are given, x squared plus x minus 12 is equal to 0, is 4 and minus 3. So these are the factors of this equation using factorization method. So let's take another example and see. Let's say example 2. We are given this 4x squared minus 20x plus 25 is equal to 0. If you remember here, what we did was x squared has no variable. That means our a is equal to 0. It's equal to 1 here. But here, we have our a to be equal to 4. So the first thing you are going to do is, you go to your rough work, for example, side of your book, then you have minus 20x, then 4 times 25 is 100x squared. So you look for a number whereby when you multiply it, you have 100x squared, and when you add it, you have minus 20x. So what are the factors of 100? They are 1, 2, 4, 5, 10, 20, 25, 50x, and 100x. So these are the factors of 25. If you take 1 times 100 is 100, 2 times 50 is 100, 4 times 25, 100, 5 times 20, 100, 10 times itself is 100. So between these two numbers, between all these, you pick 2 pairs such that when you add them up, you have 20. Clearly, if I'm to pick 2 and 50, there's no way you add it and get. But what if I take, let's see, what if I take 5 and 20? 5 and 20, when you add them up together, you will not be able to have 20 itself. So what we are going to do is, we'll pick we'll pick 10. 10x, which is this. We'll pick this. If you are given minus 10 times minus 10x, you end up having plus 100x squared. So that means if you take minus x, minus 10x minus 10x, when you multiply it, you have this, and when you sum it up, you have minus 20x. Then you have 4x squared. Instead of writing this, we'll use minus 10x minus 10x plus 25 is equal to 0. Just like we did in our previous example, then you put your bracket around, you have 4x minus 10x, then plus, then you have minus 10x plus 25 is equal to 0. So from here, what is common? Definitely x is common, 2 is common. So you have 2x. What is left here is, if you divide 4 by 2 is 2, x squared by x is x, then minus 10 divided by 2 is 5, this x is outside already. Then you have minus, because definitely what is here on here must appear in bracket here. So here what is common? 5 is common. So minus 5, then we have, the minus is outside already, then we have 2x, then minus 5 to be equal to 0. So we have this, then 2x minus 5 is equal to minus 5. Then this one also we have 2x minus 5 to be equal to 0. Since they are all the same, we can say 2x minus 5 all square is equal to 0. Since it's equal to 0, then 2x minus 5 is also equal to 0. If you take this to the right hand side, you have 2x to be equal to 5, and x is equal to 5 by 2 twice. Now, because of this square sign here, you have one factor, 5 over 2. So that means 5 over 2 appeared twice, is the root of is the factor of the equation. It appeared twice. So x is equal to 5 by 2, or x is equal to 5 by 2. So these are the factors of this equation. Then let me take one more example. Let me take x squared. X squared plus 4. Sometimes when you are solving, you end up getting a complex root like this. X squared plus 4. I said this is a perfect quadratic equation because your b is equal to 0 here. When you compare it to our initial quadratic formula, ax squared plus bx plus c equal to 0, definitely your a is equal to 1, your b is equal to 0, and your c is equal to 4. So to solve this, it is easier than all the rest. All you need to do is take this 4 to the right hand side, collect like term. So x squared is equal to, because this is a positive, you have minus 4. then x squared, then you take the square root of both sides. So square root of x squared is equal to the square root of minus 4. This square root will cancel this, so you end up having x. Now the problem is on the right hand side. There is no root of negative number. But in complex function, or let's say when you are dealing with complex number, there's this letter I is called imaginary number. It is equal to root of minus 1. To avoid having this kind of issue, then a mathematician created something like this. I is equal to root of minus 1. So in this kind of scenario, this can be written as root of minus 1 times 4. It is clearly the same thing, but what we are trying to do is we are trying to remove this minus 1 to avoid having any issue. So it is the same thing as root of minus 1 times root of 4 from indices. You split them into 2. So your x is equal to, as I said here, imaginary I. So this is equal to I. Then we have root of 4. It is 2. So we have 2. This is equal to plus or minus 2. Then this imaginary I. So in this kind of case, your x is equal to 2i, or your x is equal to minus 2i. So this is a scenario where you deal with complex numbers. Sometimes you may be given so it's not every time that you are given a perfect quadratic equation that you must arrive at a complex number. For example, let's say x squared minus 4 is equal to 0. This is almost the same thing as this, but this we deal with positive number and in our previous example, and here we are dealing with negative number. So you move the same method. So x squared, collecting items, you have 4 by moving it over the equals to sign. So from here, you take the square root of both sides. X squared root, it is equal to root of 4. In mathematics, when you are, whatsoever is affecting the right hand side of an equation must also affect the left hand side to balance it. Then this will cancel this. You are left with x is equal to root of 4. So x is equal to plus or minus 2. This implies x is equal to either 2 or x is equal to minus 2. So that's factorization. That's probably much more on factorization. Then we'll move to the second method. So in case you have any example, you can drop it in the comments below. So the next one we'll move to is completing the square. Or let's go for formula method. Some people normally call this as something almighty formula. There's nothing almighty about it. It's just that it's a little bit formula, and once you understand the basic, then you see that it's just throwing with numbers and letters. That's all. When you are first, how do you get what is the formula itself? It all starts with ax squared plus bx plus c equal to 0. For quadratic, this is the basics of everything. So you now divide through. You divide through by a. You have ax squared divided by a plus bx divided by a plus c over a is equal to 0 over a is 0. Then this will cancel this. You are left with x squared plus b over a x plus c over a equal to 0. So you collect items. Those with x you stay here, and those without x you move to the other side. So you have x squared plus b over a x is equal to minus c over a. Because of crossing the equal to sign, plus becomes negative. So at this point, you add formula method. So at this point, you add the square of half add the square of half the coefficient of x to both sides. What it means is this is the coefficient of x, b over a. So you take the half of it and square it, add it to both sides, both the left and the right hand side. So you will end up arriving at x squared plus b over a x. You say add the square of half the coefficient. So the coefficient will be over 2a all square is equal to minus c over a plus this same thing, b over 2a all square. Now b over 2a, b over a is the coefficient of x. The half is b over 2a, then the square in general. So you add it to both sides. By adding this to both sides, you have x plus b all over 2a all square. It is equal to, from here you open it up, you have b square all over 4a square minus c over a. That means the square of b is b square, square of 2a is 4a square. Then you you take the LCM of this side, which you have x plus b all over 2a all square is equal to b square. So if you take the LCM of this, 4a square, then this and this is 1, so you have b square minus a in 4a square is 4a. 4a times c, you have 4ac. You have 4ac. So you now take the square root of both sides. That's, you take the square root of this side, take the square root of the right hand side. So if you take the square root, the left hand side is x plus b all over 2a all square. It is equal to, then you take the square root of this side also. So this will go with this square. You have x plus b over 2a. Here we have b square minus 4ac over this. So you are left with x plus b over 2a. It is equal to plus or minus the square root. If you take the square root of this denominator, square root of 4 is 2. Square root of a square is a. So you are left with the numerator, which is b square minus 4ac. The next thing you have to do is you move this to this side. So you have x, it is equal to minus b all over 2a plus or minus root of b square minus 4ac all over 2a. Now, since the denominator are the same, all you say is x is equal to minus b plus or minus root of b square minus 4ac all over 2a. Now, this is the formula. So with this formula, you can be able to find any factor. Some may be complex. So for complex number, I advise you not to use this formula. But for any factors, let's say for any factor you are given, like the ones we did, it's straightforward. You can just apply your values into this. Let me take just one example. From the ones we did, example 1, which says x squared plus x minus 12 is equal to 0. From here, if you compare it to your initial ax squared plus bx plus c is equal to 0, your a is equal to 1, your b is equal to 1, and your c is equal to minus 12. So you will now take these data and input it into the formula. If you input it into formula x, it will now be equal to minus b. Your b is 1. So minus 1 plus or minus root of b squared, which is 1 squared, minus 4 times your a is 1 and your c is minus 12 all over 2a. That's 2 times 1. So minus 1 plus or minus root of 1 squared, which is 1, then 4 times 1, 4 times 12 is 48. So you have plus 48 all over 2. Then you have your x to be minus 1 plus or minus root of 49 all over 2. So minus 1 plus or minus root of 49 is 7 all over 2. Minus 1, so you have x is either minus 1 plus 7 over 2, or x is equal to minus 1 minus 7 over 2. So x is equal to minus 1 plus 7 is 6 over 2, which is 3, or x is equal to minus 1 minus 7 is minus 8 over 2, which is minus 4. So x is equal to 3, or x is equal to minus 4. So that's just the use of the formula. Instead of going through the stress of finding the factors, it gives you the factor automatically itself. So this is where we are going to stop today. If you have any question, you can drop it in the comment section. Thank you.